this car, it will take many years to become rusted, and this concrete, it will take maybe some 2 to 3 days to become hard. But this reaction, sodium chloride silver nitrate, a white precipitate will form very immediately. So this shows that different reactions taking place at different time intervals. Not all of them are happening at the same time. Then what is rate? So let's understand with examples. This aeroplane can fly around 500 km per hour, and this petrol pump can pump around 50 liters of petrol per minute, and he can bowl with a speed of 140 km per hour. So with all these examples, we can define rate as any change that happens in a single unit of time. So single unit of time can be a second, a minute, an hour, or day, or even a year. But what is our aim? What is the rate of reaction? That's what we want to study. Let's understand with example. Take zinc and sulfuric acid. So when you put zinc metal in sulfuric acid, you will observe lots of bubbles coming out initially. But after some time, what happens? It will slow down. The formation of gas bubbles will slow down. And even after some more time, the gas bubbles formation will stop. So once one of the reactant is consumed, the reaction stops. The gas produced here is hydrogen gas. So the reaction is zinc plus dilute sulfuric acid gives you zinc sulfate plus hydrogen gas. So the reactants here are zinc and sulfuric acid, and the products formed are zinc sulfate and hydrogen gas. So the rate of reaction can be measured either by the amount of zinc used or sulfuric acid used per minute, or the amount of zinc sulfate formed or hydrogen gas produced per minute. In general, for any reaction, you can find the reaction rate by how much amount of reactant consumed per unit of time, or how much amount of product formed per unit of time. Any one of the reactant or one of the products. So how do we measure the rate of a reaction? So scientists, we are scientists, so let's do one simple experiment. We'll take magnesium metal and dilute hydrochloric acid. So take the magnesium metal, first clean it with a sandpaper, because magnesium oxide layer will be there on magnesium metal, so you have to remove that. Now that cleaned magnesium you will take, and in an RB flask or even conical flask, take the dilute hydrochloric acid. So and a syringe is attached. I will show you how the setup looks. So this is the setup. You can use the conical flask or RB flask, and gas syringe is attached to it. So the moment you put the metal, that is magnesium, into dilute sulfuric acid, RB flask or conical flask, you have to start the timer immediately. Immediately you have to start the timer. So what happens initially? Immediately the hydrogen gas start forming. So a lot of hydrogen gas is produced, so that will go and collect only in the gas syringe. It has no other space to get collected. So the gas syringe initially without reaction is nothing collected. After reaction it will increase in the volume. So volume of hydrogen gas collected in syringe is noted at every half minute. You're doing an experiment, right? So you are collecting data. So what you're doing, time every half minute, volume of hydrogen gas collected at that time. So you can see from 0 to 46, 0 to 6.5 minutes, so volume 0 to 40 cm cube collected. So when you analyze this data, time versus the volume of hydrogen gas collected, when you plot the graph, it will look like this. Okay, so this graph, let's analyze what all information this graph gives us. Okay, so let's understand that with analysis of the graph. Analysis of graph results. Okay, so you can see here, this is the graph of volume of hydrogen in cm cube versus time in minute, the time of the reaction. You can see the shape of the curve is like this. And when you see the first minute of the reaction, so that is this from here, so you can see the value of volume of hydrogen in cm cube collected is this first minute. So it is around 14 cm cube in 1 minute. So what is the rate of a reaction here is 14 cm cube per minute, means 14 cm cube of hydrogen consumed in 1 minute. Similarly, when you come to the second minute, you can see what is the value, 25. So in this, what is the difference you can observe, right? So that will be in the second minute, it is 25 minus 14, means only in this minute the rate of reaction has been dropped to 11 cm cube per minute. Similarly, when you check for third minute, that is here, and the value of the volume of hydrogen collected is 33. So in this you can see what is the rate of reaction, 33 minus 25, that is 8 cm cube per minute. So what it indicates, the rate changes all throughout the reaction. It is greatest initially, and as the reaction proceeds it will decrease. You can see 14, 11, 8. Not only this, next what happens here, when you observe, the reaction is fastest in the first minute, so you will observe that the curve is the steepest, like this. Okay, and as the reaction proceeds, that less steep it will become. So you can see here it has been less steep, and once the reaction stopped, the curve goes flat. You can observe once it reached at 5 minutes approximately, it has become flat. So this is the 5 minute value. Okay, so you can see here, the faster the reaction, the steeper the curve. When the reaction is over, the curve goes flat. Okay, so altogether, if you want to find the average rate of reaction, well, how do you find it? You will take total volume of hydrogen collected and divide it by total time for the reaction taken. So total volume collected is 40 cm cube, and you can see at the 5 minutes it reached 40. After 5 minutes it remains 40, means you will take 5 minutes as the total time for reaction. So when you do that, you will get 8 cm cube per meter or 8 cm cube per minute as the average rate of reaction. So this method can be used for any reaction where one of the product is gas. Only one of the product is gas. Okay, question time. So you can check the questions for the experiment. We did magnesium ribbon is clean first. What is the reason? The clock started the moment the reactants are mixed. Okay, and go to the graph, check back and answer these two questions. Question A, how much hydrogen is produced in so and so minutes, 2.5 and 4.5, and how long it did take to get 20 cm cube of hydrogen, and what is the rate of reaction during 4th minute and 6th minute. So from the all these things you have to analyze from the graph itself. You will get it immediately. Okay, if you like the video, please share, like and subscribe. So we'll meet in the next session. Until then, take care. Bye bye.